Hey everyone, welcome back to the lab. In this video, we're going to be solving a medium LeetCode question, mostly because I have to study anyway, so might as well, make a video out of it. So I'm just going to be going through this as if I was doing a real interview, because, best practice is how you're actually going to do it. Yeah, let's get started. Okay, so the question is break a palindrome. So let's read this and see what we got to do. Okay, so basically, given a string that is a palindrome, these are lowercase. Goal is to break the palindrome, but constraint is only change one letter. Lowest lexicographically smallest possible, which I think means it's the smallest when you sort it. But let's see. So return the resulting string. If there's no way to replace a character to make it not a palindrome, return an empty string. Okay. That's an interesting constraint. Okay. If cannot replace character, empty string. Okay, so string A is lexicographically smaller than a string B. Okay, yeah, so it's basically change the thing that's smallest. It's sorting. And so when we sort, by left to right. So I don't know if I'm reading this correctly, but let's look at subproblems. A is finding character to change to make it sortably smallest. What else are we trying to solve here that's maybe hard? B, I think, is the weird one where it's like identify if cannot replace anything to make it not a palindrome. Okay, interesting. Okay, so for B, I'm pretty sure only happens if one character. Because if there's ever any more than one character, then it seems like we can replace something, and then that will make it so that it's not the same forwards and backwards. So I think this is just simple, like if it's only one character, return empty string. Otherwise, we can change it. So this is my assumption, and I can't really think of a case that breaks this. So I think this is right. The other one is finding character to change it to make it sortably smallest. So I'm thinking about this, and I think we can just do a simple, like a greedy find. And so I think there's actually two cases I'm thinking of. So in the normal case where we have like random letters that aren't all A, the lexicographically smallest thing is if we make the thing to the left as small as possible, because this is like the most significant digit, if you will, for sorting. And so basically, normal case is, search left to right for first element not equal to A. And this means that if we're assuming A is like the smallest thing because it's a palindrome of letters, A is the smallest it could possibly be. So the first time we see something that's not A, that means that thing can be reduced, and we should just reduce it. Reduce to A, because we don't actually care what it is, right? Like if it's a palindrome, the same front to back, all we have to do is just change something and it can no longer be a palindrome. I guess unless it's that middle element. So that's the problem. So all right, search left to right for first element, reduce to A. Okay, if not middle element. Okay, need to skip if middle element. So first element not equal to A, and not equal to middle element. So if we do that, then we basically change anything. It's no longer palindrome, and that's good. And because we did left to right, it must be the smallest thing possible or the most significant thing possible that we could reduce. Now, edge case, if nothing found, this means that either everything was A, everything that was possible for us to change to break the palindrome, so not the middle element, was already an A, so it's the lowest possible. So now the lowest thing that we can do, because we can't reduce anything, is to actually come from the right side and bump up whatever it is there to the next thing. And in this case, I guess the only way that we could have ever gotten here is if we couldn't reduce anything to A, which means everything's an A. So I think actually we could just bump whatever the first thing is up to B. I think this covers all cases. This is like an oversimplification, maybe too generalized, but I think what we can do is basically go right to left, bump last thing to essentially. And this will break it such that, yeah, we're either reducing as much as we can or we're increasing the smallest amount we could. And this theoretically, I think, should be the smallest like sortable thing that we found that breaks the palindrome. Yeah, that's what I think. So if we're going about this, and I guess we should think about this like to usually say, what's the best case we could think of? Best case is O of n, because we do have to go across, we have to look at the thing. I mean, we know it's a palindrome, but I think the best we could expect is for us to look at all the letters to understand what we could do to change it. So that's what I think. This one might be tricky, and it is a potentially faster one if you have like some sort of insight, but when I look at this, it seems like it's O of n is probably the best case we could realistically expect without like a crazy insight. So that's kind of the bound that we're looking for. Options A, I think basically we can just do check if changeable and then search for smallest thing to change. What I should say here is that this is an O of n1 operation. We're not really using any extra memory, or at least the memory is constant. It's O of n because we're only parsing up to 2n, right? We're going once left, once right, though theoretically just once. And then this guy is really just O of 1. So this feels pretty good here. And so basically what we can do is just say, you know, b.1 here. So check if only one character, return empty string here. If so, we can do this in, of course, O of 1. And then this one is going to be A.1 because I can't really find a better one, and O of n is the best we can hope for, I think. So we'll just do greedy find to right, and then if that doesn't work, swap to left. I think this works. This is, again, O of n1, and so if we look at this, the overall runtime is going to be O of n1, which approaches the bound that we set for ourselves, which is the best case we could probably search for. So this seems like a very decent, reasonable solution that maybe we could do better, but it's at the bound anyway. So doesn't seem we could do better big O style with the insights I currently have. All right, so let's write this. It seems pretty simple, so I'm not even sure we need any subfunctions here. So I think we can just write it in line. This is probably when I'd, check with the interviewer to see if they're okay with me going forward, if they have any questions or anything like that. But I think we covered most cases, assuming these assumptions are right, which they might not be, which we'll probably have to cover in some edge cases here. Let's try to write it. So basically we'll just say, hey, if palindrome.length less than or equal to 1, that means that, we can't change anything, so we're just going to return our empty string. So this is checking for that edge case. And then now we got to do the actual greedy find. And so how do I want to do this? Basically, I want to say const middle element equals to, let's say middle index equals to palindrome.length modulus 2 equals to 0 equals to 1. Okay, so if this is an odd thing, then we need to find the middle element. And so this is going to be, what is this? I don't know, math.floor of palindrome.length over 2. So if this is 3, then we'll get 1.5, but we're flooring it, so it's 1, which is the middle index because the middle index of 3 is 0, 1, 2, so it's 1. Okay. And then otherwise we're going to say it's null. And then we're basically going to say, now we're going to search left to right. So usually I use for eaches here, but we do want our little index guys. So I think for loop's a little bit better. I equals to 0, I is less than palindrome.length, I plus plus, something like this. And then let's get that letter out here. Letter equals to palindrome at I. And basically we're going to say if, let's check the middle index thing. So index is not equal to null, and I equals to middle index, then this means we're at that middle index. And again, the middle index only exists if it's odd length. If it's even length, then the middle ones, you can actually change either one. So we only care about the middle index if it's even. So basically, if it's not equal to null and I is equal to the middle index, then we can't change this thing, so we're just actually going to continue. So that means now we've gotten to a point where we actually, and let's just move this down, doesn't really matter, but don't need to allocate a variable if we aren't going to use it. So now this means that we're at an index where we actually could change something. So let's actually check if we can change it. And so basically what we're going to say is just be really dumb. We're just going to say if this is an A, then it's not the smallest it could be. And this is the thing we can change. And so we're going to say something like, if letter is not equal to A, then we found the thing, and we need to do return with A swapped. I'll think about how to do this. I might want to actually write a helper function to do this one. Otherwise, if we've done that and they're all equal to A, then basically what we're going to do is we're going to say HAMY to do return with last letter equal to B. All right, let's think about how to actually change a string. I don't know how to swap strings. So I'm gonna look this up real fast. JavaScript copy string. I don't like changing things in place, so this is why I'm kind of thinking about this. String copy. So I want a copy of this string. I don't actually, oh yeah, it's just this dot substring. Okay. So I'm actually gonna say that, let's make the copy up here. So we're gonna say let string copy equals to palindrome dot substring 0. So I think, let's see, JavaScript substring. I think this is a start index, and then it just goes till the end if I don't provide anything. So the first one is, start position, first character is at index 0. So theoretically, this should copy the whole thing, I think. And then now that I have the string copy, I am just going to mutate it. So we'll just say that string copy at, I think I can do this, I equals to A, and then return string copy. Ooh, it really doesn't like me doing this, huh? Let's see, how do I swap? Let's see, JavaScript, swap, character, and string. Okay, so I kind of have to use a substring anyway. So let's make it, right? So let's do const swap character and string equals to original string is a string, index to swap is a number, and then we'll say something like character to swap string, something like that. Returns a string. And so this, what we need to do is basically say return original string. It's kind of annoying. Dot substring of 0 to index to swap, I believe. Yes, because this is end position is up to but not including. So yeah, if the original string is this and the index to swap is 0, for instance, we do want to just have the index there because then it will not have that one. And then we'll have character to swap. And theoretically, this isn't just a character, this works for any string. But for the domain, we'll just use it here, though it's kind of disingenuous. And then what we want to do here is probably just, index to swap here with no end, so it goes actually index to swap +1 because this is inclusive, and then so this is how we're effectively putting the thing in there. Okay, so this is our little helper guy, and then we can say something like this. So return swap character and string like this, and now we actually don't even need the string copy, so we're not even creating this extra memory, though I guess we're kind of doing it temp here, which we have to do anyway because we got to create a new string to return. So we got our original string, which is the palindrome. The index to swap at is I because we found that this is the one that we want to get rid of. And then the character to swap is we want to actually turn it into an A. And so theoretically, this works for us. When we run it, maybe there's a bug in here, but I think this makes sense. And then if we can't do that, then we're actually just going to do the same thing. So we'll just use the exact same thing here. So it's palindrome. Instead of doing A, we want it to be B, just because at this point we know that everything must have been A because we couldn't find anything to swap. So we'll just take the last thing and return it. And we just have to change this out. So, it's not the end of the string, but it's palindrome.length -1. So the last thing there. So theoretically, what happens if the substring is out of bounds? I don't know. Let's find out what happens when it's out of bounds. I have this little helper thing up here, I suppose. And it's saying, let's see, run it. What's this saying? Oh yeah. So what happens if we do it out of bounds? If we do .length, does this return nothing? Yeah, it doesn't look like it's erroring. Let's see. Is it erroring? Console. That's not our problem. Someone else's problem. from. So yeah, it's just returning this. If we do -1, is this still happening? Yeah, okay. So it looks like it'll just do an empty string at the end. So that's good. So it looks like we can just rely on JavaScript's ability to do this. So if we do pass this in, and this guy says, palindrome.length, then it'll just return nothing, so that we are effectively swapping the thing at the end for B. So yeah, this looks like what we want. So now let's just kind of walk through it here. Basically what we're doing is you're calling break palindrome. The first thing we're going to do is just check if it's impossible to break the palindrome. It seems to me, my assumption is the only way that it would be impossible for us to break a palindrome if it's nothing in there, or if there's only one thing in there, because there's no way to change it so that it's not the same left to right. Otherwise, there's something we can change to make it not a palindrome. We are just assuming this is a palindrome, which I think is okay given the context of the question, but that might be something we'd want to check first. The next thing we're doing is saying if there's a middle index, because if there is a middle index, then this means that there is something that we can't greedily change to break the palindrome, and that will be the middle thing, because no matter what you change in the middle, the things on the sides are the same, so still be a palindrome. So we check that by basically just saying, hey, is this thing odd? We're doing that by checking the length, seeing if mod 2 is equal to 0. If it's equal to 1, then that means it is odd. And then we're saying, all right, if it is odd, then the middle is going to be the floor of palindrome.length over 2, which we already checked this earlier. And then if otherwise, it's just going to be null, which we're using as our, nothing exists here kind of value. Now we're just going to say, basically iterate from left to right to find the first thing that we can that's not the middle index, that is not an A. And the reason we're doing this is because, again, we're looking for the smallest thing, and, the most significant digit is on the left, if you will. And so the first thing we find that is not an A, the smallest we could make it is to just reduce that thing to an A and return it. So we're pulling out the letter here. We're saying, hey, if you're not equal to an A, then we want to return the swap of you, which we built our little custom function up here. And then if we can't do that, then basically what we're going to do is we're just going to find the least significant digit, which is a thing on the small side, and we're just going to increment it by 1. We know that this must be an A because we weren't able to change anything to reduce it. So it must be A at the end, and all we got to do is just swap it B, which effectively increases it by 1, which is the smallest you can possibly increase it. Okay, so that is what we want, and let's look at our little swap character and string guy just to make sure it makes sense. So this is just a little helper because you can't just mutate a string, which is the same across most languages, but I thought JavaScript might be different. It's not. Basically what we're doing is we're just substringing 0 to index to swap here, and this is exclusive. And so then we're just putting the character in there, and then we're saying, hey, substring from index to swap +1 to the end. And we already checked if it's out of bounds, it's just nothing. So this effectively replaces that character. Got to be careful about these things because of the runtime, but I think this is just O of n theoretically. So this seems fine and is within our bounds. Yeah, and I think this does what we want it to do, but let's run it and find out. Okay, looks like it checks the boxes here. Now let's submit to see more test cases. Awesome, works as expected. All right, not bad. For memory, I think we're definitely doing all right. For the runtime, looks like we're a little slow. Not exactly sure why, so maybe we're a little bit off, but I think O of n is still pretty decent. I don't know what the exact best case is that you could possibly get here, but I think O of n is usually acceptable. I'd probably rate this as a mixed pass, not a great pass, but mixed pass, because we did get best bound, even if it's not necessarily optimal. We did have some relatively clean code, walked through it and stuff like that, but it did take quite a long time for a medium. This is about at the 25-ish, 24-ish minute mark. And also had some issues with the kind of JavaScript standard library around kind of iterating over characters, swapping characters and stuff like that. So any of those things are I don't think they're red flags, but they're little yellow flags, and if you have enough of them, that could kind of sway either way. So I don't think this is a pure true pass, but a decent pass probably, which is a few little yellow flags. Yep, that's it for this video. That's kind of how I interview for questions like this. Let me know if you have any comments. Otherwise, I will see you in the next one.